Hi, Lori. I'm sorry. First of all, I'm sorry this took so long to get it made. Second of all, I forgot my pen to write on my Surface at home. So I'm gonna have to do this typing as best as I can, but hopefully with me explaining it, it will go okay. So it says of the 40 people who answered yes to a question, 11 were male. Okay, so kind of already we know we're gonna have people answering yes or no. And those people can either be male or female. So let's read that first part again. Of the 40 people who answered yes, so total across here will be 40, 11 were male. So we have 11 here, and then if we do 40 minus 11, we'd have 29 here. And it said of the 62 people who answered no, 15 were male. So we would have 15 here, and then 62 minus 15 is 47. Okay, so then it says if one person is selected at random from the group, what is the probability that the person answered yes or was male? So we're only going to have one fraction, okay? And so we're going to have a fraction. So our top, we want how many people are yes. So let's always start with the bottom. So the bottom is going to be the total number of people. And up top, we want the number of people who answered yes or male. So yes or male would be all the people here plus these people here. So if we had 29 plus 11 plus 15, that would give us 55. Over the total number, if we add all four numbers up, we get 102. So if we take in our calculator 55 divided by 102, we'd get 0.539. Okay, so that's question number 2. Okay, let's go to question number 4. So the following table contains data from a study of 2 airlines which fly to small town USA. So notice we have 2 airlines, Podunk and Upstate, and we have flights that were on time and flights that were late. Okay, so hold on, I'm not able to see all of this right now. Okay, so it says if one of the 87 flights is randomly selected, find the probability that the flight was selected is an Upstate airline given that it was late. Now, there's that special word given. That means the bottom, the denominator of our number is only going to be the part that's after given, only the late ones. And then we want the top will be the Upstate airlines that were in the late category. So late total, if we add the late ones, that's 11 total. And the Upstate airlines that were late, that would be this 5. So we'd have 5 over 11. So just remember, so I think you did 5 over the total. I'm not sure exactly what you did, but when it says given late, that means late. We're only going to look at that column, both those numbers. Okay, number 5. So, sorry, again, I can't read the whole thing. Okay. Okay, hold on. I'm going to pause this so I can go get the whole. So here's the problem. So it says you are dealt 2 cards successively, so without replacement, from a shuffled deck. Find the probability that both cards are black. So since we're doing 2 here, we're going to have 2 fractions that we're going to multiply together. Oops. So the probability that the first one's black, sorry, I guess I'm just going to type it up above here. So we want the first one black times the problem that the second one is black. So we've got a total of 52 cards, and 26 of them are black. So the first one would be 26 over 52. Then we would multiply by, we're not putting that one back in the card, it says without replacement, so multiplying by 25 over 51. Okay, and then you would reduce that. So the first fraction actually reduces to 1/2. So this reduces to 25/102. Okay. Okay. So this says, for the given pair of events, classify the events as independent or dependent. So it says randomly selecting a lawnmower owner and randomly selecting a homeowner. Now, if someone owns a lawnmower, it's more likely that they own a home, because most people wouldn't have a lawnmower if they don't own a home. So these two would be considered dependent. Okay, so this one says, I think this is the last one. The following data summarizes the result of 958 pedestrian deaths. So that's how many we have total here. If one pedestrian death is randomly selected, find the probability that there... Oops, again, let's go back to this. Find the probability that the pedestrian was intoxicated or the driver was intoxicated. So pedestrian intoxicated, that's going to be those two numbers, or the driver intoxicated, these two. So we want to take these three numbers, the 91, okay. So the pedestrian intoxicated would be 60 plus 255. And then the driver intoxicated, we've already added the 60, so we just need to add the 91. And this would all be over the total of 958. So if we do 60 plus 255 plus 91, we have 406 out of 958, which is indeed 0.424. Okay, so why don't you come to my office hours tomorrow and I can go over anything that didn't make sense from this video. Sorry, I didn't have my pen to write with, and we'll go from there.